So in this video, we're going to be simplifying trigonometric expressions, okay? We're going to use fundamental identities to do so, all right? So I've listed a lot of the fundamental identities here. The reciprocal identities we're going to focus on. We've got these 6. Sometimes these are referred to as quotient identities, and the Pythagorean identities we'll focus on here. In the examples I've got, we're not going to be using either of the even, odd identities or the cofunction identities, okay? So let's take a look at number 1. We've got cosine of t plus tangent of t times sine of t, all right? And we want to simplify this using those fundamental identities until we get something that's, again, like simplifying fractions, it's in simplest form, all right? So a lot of times what you want to do when you're doing this, and we're going to do the same process when we're verifying identities in the next set of notes, one of the things you can always do is try to write things in terms of sine and cosine, okay? So obviously these two terms are already written in terms of sine and cosine. So let's rewrite tangent, okay, in terms of sine and cosine. So remember, tangent is sine over cosine, all right? So now I've got everything in terms of sine and cosine. So let's just kind of do some algebra here and see what happens. So with this one, I'm going to go ahead and multiply, okay? And I get cosine of t plus sine squared over cosine, all right? Now, we're adding these two expressions. One of them is a rational expression, a fraction here. So we need to convert this other one to a fraction with the same denominator, okay? So let's get a common denominator there. So when I simplify now, I've got cosine squared plus sine squared over cosine of t, okay? Now, one of my Pythagorean identities, remember, is sine squared plus cosine squared. That can be simplified to 1. So we can substitute in a 1 in the numerator because of that Pythagorean identity, okay? So that's 1 over cosine of t. Now, 1 over cosine of t using one of our reciprocal identities is equal to secant, okay? So we simplified this expression, which was a lot more complicated, down into this one individual expression, secant of t, okay? Give number 2 a try and then come back and check your work. All right, so in problem number 2 here, we're actually going to factor first. If you'll notice, each of these has a cosecant of x in common. So we can take that cosecant of x out as a greatest common factor, okay? What that leaves inside is cosecant squared of x minus cotangent squared of x. Right now, what's inside of this parentheses is it's a variation of one of the Pythagorean identities, okay? So if you were to simplify the Pythagorean identity, let's scroll back up here. We want to look at this one, okay? If we were to move cotangent squared over to the right side here, you could see that cosecant squared minus that cotangent squared is equal to 1, okay? So I can substitute a 1 in here using that variation of that Pythagorean identity. So I've got cosecant times 1, which is just going to be cosecant of x, okay? All right, pause it, try number 3, and then come back and check. All right, so on problem number 3, we've got 2 rational expressions here. So one thing we can definitely do is get a common denominator, and so we can combine these two, okay? So my common denominator is just going to be the product of these 2 denominators. So on the left side here, I'm going to need 1 plus sine of x to be what I'm multiplying both top and bottom by. On the right side, I'm going to need cosine of x to add on to be the common denominator on the right side, okay? So remember, when we simplify rational expressions, we're going to leave our denominator in factored form, but the numerator, we need to use our algebra and multiply these out and then kind of see what happens from there, okay? So on the left side here, I've got 1 times sine, which is sine, and then sine times sine, which is sine squared, okay? All over my common denominator. On the right side, my numerator becomes cosine squared of x, okay? And then I have my common denominator, all right? So now I've got 2 fractions with a common denominator, so I can add those, okay? And what we see here, again, this is a pretty common identity to use, that sine squared plus cosine squared is going to equal to 1, okay? So I'm going to replace that with a 1, okay? And now what I can notice is this factor, sine of x plus 1, and 1 plus sine of x, that commutative property there, makes these 2 equal. So I can cancel those out, all right? So now my numerator is 1, and my denominator is cosine of x, okay? And just like problem number 1, that's going to simplify to secant okay? So I've simplified this pretty complicated problem up here, the addition of two rational expressions with trig functions, into this one basic trig function, secant of x, okay? Pause here, give 4 a try, and then come back and check. All right, so number 4 is probably one of the most complicated ones we've had so far. We're going to go back and use the method we used in number 1. Let's just go ahead and write everything in terms of sine and cosine, okay? So I'm going to rewrite secant as 1 over cosine, and I'm going to rewrite tangent as sine over cosine, which is going to make it look like this, okay? Now, within my numerator, I have to get a common denominator. That's really the only algebraic step I can take right now. So my common denominator within this numerator here would be cosine of x. So I'm going to multiply that second term by cosine of x over cosine of x, all right? So when I simplify, I get 1 minus cosine squared of x over cosine of x, and my denominator stays the same, okay? So now I'm going to flip this and multiply, okay? So my numerator stays the same, and then I'm going to multiply that by cosine over sine, okay? So I'm going to use an identity here before I start canceling things out. I want to use an identity here for this numerator. So 1 minus cosine squared is equal to sine squared. And then my second expression here doesn't change, okay? So this is going to be pretty nice and neat here, okay? Those cosine of x's cancel out, okay? I've got a sine of x in the denominator here. I've got 2 of those here, so I can cancel out 1 of those in the numerator with that one in the denominator. So you can see all I'm left with when I do all my simplifying process is just the sine of x, okay? So that's how you simplify trigonometric functions using fundamental identities.